Now this is an integral that looks very straightforward, but you might want to have a discussion with yourself of what method to use. And remember, when you're picking the method, start from the easiest methods. So in other words, is there a composition function here that when I take the derivative of the inside of the composition, it's sitting on the outside? No. So substitution won't work. The next one, that's just the one step harder if you think about it, is parts. And I believe parts will work here. Now, the rule to parts, I'm going to write down here. It's the integral of u dv is equal to uv minus the integral of v du. Now, what a lot of students do is they ignore this bit right here. This right here is actually very, very important. Very important. Because that means that your original integrand has to be in this form u dv. So that's why when you pick your substitution to do parts, you have a u and a dv. And the product of those two things that you write down here has to look just like your integrand. That's why we always tell you this part over here, okay? So if we do this correctly, because there's no natural log in here, I'm going to pick the polynomial to be u, and I'm going to pick dv to be e to the x dx. Now, if I look at this, if I take u times dv, it looks just like my integrand. So this may or may not be the right choice, but at least I have my u times dv right in order to use the formula correctly. Well, I'm going to take the derivative here, so du equals dx. And then I'm going to integrate back up here, so v equals e to the x. Now, that's pretty straightforward. If this is like e to the 2x, e to the minus x, you know, until you're a superstar in algebra, I would suggest you, off to the side, use u substitution to do this integral, okay? Now, I'm going to use my formula. U times v, and then don't forget your limits. Without the limits, it's wrong. Minus the integral from v du. Now, if you did parts right, this should be easier to integrate than what this was to integrate. If this is harder, say it's x squared, or somehow some other weird thing shows up other than x, then something happened in the way that you set up your parts. All right, now, let's keep going and just finish this right off. So I have x e to the x from 0 to 2 minus, now the integral of e to the x dx is e to the x, and that's also from 0 to 2. I don't need a plus c here because it's a definite integral. Now you can do this one of two ways. You can take out the 0 to 2, write it like this, x e to the x minus e to the x from 0 to 2, the whole thing. That's totally legal. So let's keep going. I plug in a 2. And I'm going to subtract off plugging in a 0. Now here's a word to the wise. Students love to say, oh, that's 0, so that's 0. It's not true. And this is a really great case in point. So I have 2e squared minus 1e squared. That just leaves me with 1e squared. But over here, yes, that is 0 right there because it's 0 times a number, but this is 1. So I'm minusing a negative 1, so that's plus 1. And then there's my final answer.